In our second unit, we're going to be focusing on surface area as well as volume. So let's work through here. We're going to skip over this part here and just move into this getting started. So number one here, it says match each area to an object it could describe. So here you're going to have to know what approximately a centimeter is, what approximately a foot is, a meter is, an inch is, and a yard is. So a centimeter is about the width of your index finger. So if we had something that was 4 centimeters squared, that would be, if I drew a little diagram here, that would have 4 square centimeters in it. I guess this should be a little more even, like that. So that would mean one side of it is 2 centimeters and another side of it's 2 centimeters. And if we were to find the area of this square, it would be 2 times 2, which is equal to 4 centimeters squared. So something that would approximately be that size would be a postage stamp. Next, let's look at 1 square foot. So a foot is about the size of a human foot. I mean, everyone's feet are different sizes, but approximately the size of a human foot. It also is about it's the exact size of a tile on the floor of the classrooms at the school. So 1 foot is like the length of that tile. So something approximately that big squared would be a binder. Now let's look at 2 meters squared. So a meter, I think most of you know what a meter stick is. So something that would be 2 meters squared approximately would be a bed. If we're looking at 8 square inches or 8 inches squared, an inch is about the size of the first joint on your thumb. So if you bend your thumb and you go from the tip of your thumb to where it bends at the joint there, that little section is about an inch. So 8 square inches would be pretty big, but not too big. A good comparison would be like the size of a cell phone. Now, obviously, cell phones aren't square, but it's approximately that size. And now 1 square yard. A yard is about the same size of a meter stick, give or take a little bit. So 1 square yard would be approximately the size of a window. So now let's do some evaluating here. They want us to do 23.5 meters and they want us to square it. So in your calculator, find that little square button and do 23.5 squared, and we get 552.25 meters squared. Next, they want us to do the square root of 25 centimeters squared plus 144 centimeters squared. So let's start by adding those two numbers together. 25 plus 144 is 169 centimeters squared. And if we square rooted that, we get 13 centimeters. So here's a few shapes that we can find the area of. Let's start off with the first one here, A. So A here would be a rectangle. And to find the area of a rectangle, all we have to do is length times width, as you can see on the side here. So we're going to do 5 times 4, or in other words, that would be 20 feet squared, or 20 square feet. The next polygon is named a triangle. And to find the area of a triangle, if we look on the side here, the area is equal to 1/2 times the base times the height, base and height. So the base is going to be this number down here, which is 6, and the height is this one here, 8. So we're going to do 1/2 times 6 times 8. And if we plug that in our calculator, we get 24 centimeters squared for the area. Next, this shape here, all the sides are parallel to each other, meaning they would never touch. So these two sides are parallel, and these two, they're never ever going to meet, no matter how far they continue on. Therefore, this is a parallelogram. Parallelogram. Because all sides are parallel to each other. Well, not all sides, but all matching sides. So the area of a parallelogram, as they show us here, is just base times height. So here's our base and here's our height. Let's do 17 times 11. And so the final area we get is 187 meters squared. And don't forget to write meters squared for our units. And finally, this last one here is a trapezoid. And the formula they give us over here is a little bit complicated, so let's try to look into this. We have 1/2 times little b plus big B, so that's like the little base, times the big base, and then all of that is times the height. So let's plug in some numbers. 1/2, now let's open our bracket. The little b in this case is going to be this number up here, so 8 plus big B, which is 18. Then I'm going to close that bracket and I'm going to put the h there, which is the height of the entire thing, which is 6 times 6. And I'm using this dot, which means multiplication. So if we plug this in, we would have to use BEDMAS. So you could plug this all into your calculator straight away. I'm going to use BEDMAS and I'm going to solve this little part in the brackets first. So 8 plus 18 is 26. So now in my calculator, I'm going to put 1/2 times 26 times 6. And if you do that, you should get 78 inches squared. So moving on to the next page here, let's look at how to find the circumference and area of a circle. So they give us the formulas over here. We have one for circumference and one for area. These formulas are really similar to each other, so it's easy to get them mixed up. It's also easy to get mixed up with the diameter versus the radius. So remember, the radius is only halfway across the circle, whereas the diameter is the entire way across it. How I remember is that diameter is a longer word, therefore it's the longer distance. Radius has less letters, so I just think of it as half the circle. So now let's look at A. We need to find the circumference of this circle here. So our circumference formula is either going to be pi times the diameter, or we can use 2 times pi times the radius. So if we look at A here, they want us to start off by finding the circumference. Now the circumference is the distance around the circle. So let's just put that here. Circumference is distance around the circle. Or in other words, like the perimeter of the circle. So to find the circumference, we are finding the distance all the way around this circle. So this one here, we can use one of two formulas. We can either use pi times diameter, or we can use 2 times pi times the radius. In example 4a, they give us the radius. So I'm going to use the second formula here. So we have 2 times pi, and the radius we have is 3. So 2 times pi times 3. Now in your calculator, you're going to punch this in, but keep in mind, if you're using a scientific calculator, there is a pi button on it. So you can use that pi button, or if you don't use a scientific calculator, you can also use 3.14 to represent pi. If you're using your phone, if you tilt your phone to the side and put it horizontally, the pi button should appear, so you can just use that. So now I'm going to type in 2 times pi times 3, and I get 18.849, and so on, yards, or about 19 yards if we were to round that up. Now let's look at the area. So the area is everything inside the circle here. So the formula we have for area is over here, pi times radius squared. Now keep in mind, the only thing being squared is the radius. The pi isn't going to be squared. So when I plug this into my calculator, I like squaring the radius first and then timesing it by pi. So here we have pi times radius, which is 3, squared. So what I would do is do pi times, and 3 squared is 9, because that's 3 times 3. So in my calculator, I'm going to put pi times 9, and I get 28.274, and so on, square yards, or about 28 square yards if we round that down. So let's try another one here, but this time they give us the diameter. They give us the distance all the way across the circle. So this time for circumference, let's use that top formula here, pi times diameter. So pi times the diameter, which is 8. Or in other words, if we plug that into our calculator, we get 25.132 and so on meters, or about 25 meters if we round that. Next, we need to find the area, but if you remember from the area formula, we need the radius of the circle to do that. So let's start off with finding the radius, r. So r is equal to half of the diameter. So we're going to do 1/2 times 8. Half the diameter And let's just make sure we know r is radius here. So 1/2 of the diameter, or 1/2 times 8, is 4. So our radius is 4. Radius is equal to 4, and this here is the diameter. So now if we were to use our area formula, we're going to do pi times radius squared, or pi times 4 squared. And remember, I like to square that 4 before plugging it in my calculator because the 4 is the only thing being squared, not the pi. So I'm going to have pi times 4 squared, which is 16. Pi times 16. So if we plug that into our calculator, we should get 50.265 and so on meters squared, or about 50 meters squared. So now let's look at this one. Tula works at an aquarium store. She uses area formulas to estimate how many fish an aquarium can hold. For freshwater tropical fish, the formula is the area of top of the tank divided by 12 square inches equals the number of fish. So how many freshwater tropical fish can live in this aquarium? So the first thing we need to do is we need to figure out the area of the top of the tank. So I'm going to do that in pink. So area of the top of the tank, well, here's the top of the tank. So the area of that is just going to be, well, the shape of that is a rectangle, so it'll be length times width, or in other words, 18 times 48. And if we are to plug that in our calculator, we should get 864 inches squared, because we're dealing with inches here. So now let's take that and let's divide it by 12. So I'm going to do that in green. So now we're going to do 864 divided by 12 is equal to 72. So here is our answer. We're going to say about 72 fish can live in this aquarium. And it's always good to put a nice final sentence for any word problem. And now finally we have Tula's aquarium on the right is 24 inches high. So here, let's plug in that dimension before we forget. So here to here is 24 inches. What is the total area of all the outside surfaces in square inches? Include the top and bottom. So if we're looking at all the outside surfaces, let's start with the top and bottom. Top and bottom, because those two are going to be the exact same size. So if we're looking at the top and bottom, the area, well, we already figured out what the area of that pink part was here. So the area of that pink part is 18 times 48, which we got 864 inches squared. But since we're doing the top and bottom, let's times that by 2, since there's two surfaces with that area. So in total, we have 1,728 inches squared. We'll put a box around that. So next, let's look at the sides. How about that? We're going to look at this side here and this side here. So let's start by finding the area of one of the sides. So if we're looking at the dimensions, we have that this over here is 24 and this over here is 18. So if we draw this out, we have 24 and 18. So we're going to have to do the area of that, which is 18 times 24, which gives us 432. And then we're going to times that by 2 again, since there are two sides, the left side and the right side. So if we times that by 2, we get 864 inches squared. And then finally, let's do the front and the back of this tank. So we have the front here, and of course the matching side on the back there. So front and back. So if we're looking at the dimensions of those ones, it looks something like this. We're going to have 48 inches on the top here, and then this side here is 24. So we're going to have to do 48 times 24, and I'm just going to plug that in my calculator. 48 times 24 is equal to 1,152, and then we're going to times that by 2. So then we get 2,000 2,304 inches squared. So now we have to calculate the total surface area. So we're going to add up all of these amounts that we got here. So the total surface area is equal to 1,728 plus 864 plus 2,304. And if we tally all those up, we get 4,896 inches squared. That there is the total surface area. So we found the area of every single surface of this object.